Welcome to the first of many videos for Algebra 3-4 for Miss Andrews' class. Today we're going to be reviewing slope and linear equations and getting into what's called the general form or the graphing form of an equation. The warm-up task that we did, each group was given a piece of paper with 2 coordinates on it, and you find as many things as you can. People came up with slope and positive slope or negative slope. They came up with the equation. They came up with the y-intercept. They did that by graphing. They did that algebraically. And those are types of things that we are going to work on today. So the first of those things is finding the slope from 2 points. It doesn't matter if you are labeling this is x2 and y2, or this is x1 and y1, or vice versa, as long as these 2 points and these 2 points are coming from the same coordinate. So just make sure you're not switching those up, and always make sure that your y's are on top. So to find the point given a set, to find the slope given a set of points, we can start by determining which one is x1 and y1, x2 and y2. And that was pretty arbitrary, which ones I decided to do there, so don't feel like that's going to be like you have to make one 0.1 and the other 0.2. It doesn't really matter. So y1 is 8. I'm going to change colors here real quick. So we've got 8 minus negative 4 for y2 over negative 1 minus 2. One of the biggest issues that people often have with finding the slope has to do with negatives. So make sure that this is always staying negative. That's always a minus because you're finding the difference in the y's and the x's. And then if you have a negative number, that is also staying in your equation. And then after that, simplify. So 8 minus a negative 4, that's the same as 8 plus 4, so that's 12. And then negative 1 minus 2 is negative 3. So here we have a slope of negative 4. On part B, I'm going to do 18 minus 0 divided by 1 minus a negative 8. So that is 18 over 9, which is a slope of 2. 5 minus a negative 7 for our difference in y's, 9 minus 3. 5 minus a negative 7 is 12. 9 minus 3 is 6. So that's going to give us a slope of 2 as well. 8 minus a negative 1 divided by 5 minus 3. That's going to give us 9 over 2. And you can put that as a decimal if you prefer. However, I would recommend leaving it as a fraction. Slope is rise over run, so when it's in a fraction, that's actually a little easier to deal with, and we'll talk about that in a minute. Negative 5 minus negative 11. Negative 4 minus, and whoops, negative 1. I need to change that. So that's the same as negative 5 plus 11 and negative 4 plus 1, which gives us 6 over negative 3, which is negative 2. Finally, negative 30 minus a negative 30, negative 12 minus 4. That's going to give us, I'm going to put a line here, 0 over negative 16. And 0 divided by anything is going to be 0. You want to be careful with that because if you end up dividing by 0, that is a vertical line, and it has an undefined slope. However, in this particular situation, because we have a 0 slope, that would be just a flat horizontal line if you were to graph it. Finding the slope from a graph, you want to look at where we have 2 points that cross on grid lines, so you just follow the line until you find points that are exactly on the grid line so you don't have to estimate. And I usually go left to right, so up or down first. So I'm going to go up 3 and over 5, so that means my slope is 3/5. So finding the slope from these graphs, I'm going to go from one point to the next. So up 2 over 4. You can also see this would be up 1 over 2 if you use that point right there. So the slope can be written as 1/2 or 2/4, but 1/2 is the more reduced one. On part B, I'm going down first, so I'm going down 4 over 1. So that slope is going to be -4 over 1, and you can write that as -4 over 1, or you can write it as -4. In part C, we're going down 1 and over 1, 2, 3, 4, 5. So -1 over 5. And it really doesn't matter where the negative is as long as you don't double it up on accident. You can write it as the whole fraction or the top or the bottom, just as long as only one of those is negative. Finding the y-intercept from the graph can be really easy if it falls on a grid line. This one is a 0.05. Some people might refer to that just as 5 for the y-intercept, but remember that it is a point on the graph. So here we have a y-intercept of 0, -1. Here is at -6, 0, -6. And here is a little bit trickier. It's not falling on a grid line, so we have to estimate. We can figure this out by slope. This is actually -1/5. But there is a better way to figure that out, find out our equation if we have a situation where it's not coming out very nicely at the y-intercept. One thing I do want you to note, on all of these, we have 0 for our x value at the y-intercept. That's because on the y-axis, so I'll look at part C here, this is your y-axis right here. On the y-axis, everywhere along there, x is going to be 0. So algebraically speaking, if you're finding the y-intercept, you're looking for where x is 0. Finding the equation from 2 points algebraically. There are 2 different ways to do this. I'm going to show you both ways. We always are going to start with the slope. So let me change colors here. So I'm going to do -5 minus -1, -9 minus 3. So we've got -5 plus 1 is going to give me -4, and -9 minus 3 is going to give me -12. So a negative divided by negative is going to give me a positive, and then 4 over 12 is the equivalent of 1/3. So I have a fraction for a slope. One way to do this is by using the y equals mx plus b. Whoops. Where m is your slope and b is the y-intercept that we have to solve for. So you can put it in that form. And then you have 2 x and y values right here and here, so you can use either one. I'm going to go ahead and use the 3, -1. So I'm going to put -1 in for y. I'm going to put 1/3 for my slope. And I'm going to put 3 for my x value. And then plus b, because I don't know what b is. So -1 equals 1/3 times 3, and multiply the whole number by the numerator, so that gives me 3 over 3, which is just 1, plus b, subtract 1 from both sides, so I've got -2 equals b. So that means my equation is y equals 1/3 x minus 2. So that's one way to go about it. These I'm going to go ahead and leave. Yeah, maybe not. So if I have a slope of -2 passing through 0, 6, that's my y-intercept because x is 0. So I've got y equals -2, x plus 6. That one is simple enough. This one, I don't have the y-intercept, so I'm going to put 3 in for y. Slope of 1/2 times 4 for x plus b. This gives me 2. Drop down everything else. So I've got 1 equals b. So y equals 1/2 x plus 1 for that answer. In the interest of time, for C, D, and E, I'm not going to worry about doing those. You find the slope using the same equation, and then find the y-intercept. On part F, we have come into an issue because -7/11 is a rather unpleasant fraction to deal with. And so what we're going to do is I'm going to introduce what's called the, okay, in just a minute. Hold that thought. So finding the equation from a graph when it's not clear where your where your y-intercept is. On this one, my y-intercept is somewhere down here, and on this one it's right here, but it's really hard to tell what it is. So in those cases we have, I'm going to come back to that one, we have the point slope formula. Now with this formula, you may have seen this, maybe not. We solve this for y and do the plus y1. But we put this in kind of our own form. So this would be y equals m x minus x1 plus y1. So what we're really looking at here is what's called the general form of our equation. And we use that as hk, where so y equals a times x minus h plus k. So a in this equation is your slope, and then the point hk is any point on the graph. And this is for linear equations. In chapter 1, or in unit 1, we're going to get into nonlinear equations when you use a lot of different forms of this. But for now, this is any point on the line. So this makes the whole thing much easier to deal with when we have things that are not, when we have things that aren't coming out as nice numbers. So if I look at something with a slope of looking at 6a, a slope of -7/11, right at the top, I'm going to write my general form here. So y equals a, x minus h plus k. So this is going to be y equals -7/11, x, and then my x value for my hk is 10, so x minus 10 plus 8. One thing you want to be careful about is knowing that that right there is a minus. So when you start it out, it stays a minus. So on part B, y equals 1/2 x minus a -4.2 plus 3.1. So when you write this overall, it's going to be y equals 1/2 x plus 4.2 plus 3.1. So here on part C, if we find our slope, down 2/3, so -2/3. And I'm just going to pick one of these points. So this first point here is the point 1,7. So when I write this is going to be y equals -2/3 x minus 1 plus 7. And that is the point slope form, the one we're going to be working with from here on out. And that's it for section 1.